Okay, I'm sorry about that. I am back with the second part of this piecewise function. And so here we were on the second part with the purple graph, and we're just choosing x coordinates that will fall into the interval -3 to 4. And I left off picking 0 as my x coordinate. Picking 0 as an x coordinate will give me -1 for the y coordinate. And then you could pick another, you could pick whatever you want. It's just got to be between -3 and 4. But at some point, you do need to finish with the +4. I think I said -4, but I meant the +4. And it doesn't matter what you choose. If you choose an x between the given interval here, you will see that it doesn't matter what you choose because y is always going to be -1. Lastly, let's finish up with the green piece. And we have to pick x's that are greater than 4. Just like we did for the blue piece and the purple piece, we have to start with 4. When we go to graph this one, we will use an open circle because you see it says x is strictly greater than 4, not equal to 4. But you still have to use that as a starting point. So use 4 and substitute 4 into x. 1/2 times 4 will give us 2. Now continue to choose x coordinates that will fit this constraint, which means x has to be greater than 4. So I'm going to choose 6. We'll find that y is 3. And then choose another x. I'm going to choose 8, and you'll see that y is 4. Again, at any point during these videos, pause the video. Think about what we're saying. Rewind it, play a piece that I've said to really absorb what we're doing here. Pause it and try to do it on your own before you move forward. Okay, so let's graph these pieces to this function. I'm going to graph the blue piece first. You'll see that all of these are linear because none of these have exponents on the variable. So when I graph the blue piece, I'm going to graph these 3 ordered pairs and I'm going to connect them using a line. So -3, -4. Now, are we going to use an open circle or a closed circle here? We're going to use a closed circle because it says x is less than or equal to -3. So here we do include the -3. And then we'll graph -4, -5, and then -5, -6. For the second piece of this function, we're going to graph these 3 ordered pairs here. Now, hopefully, if you see that f of x equals a constant, you realize that this is just y equals that constant, right? If y equals a constant, what type of line are you looking at? Are you going to be looking at a vertical line or a horizontal line? You're going to be looking at a horizontal line. So when we graph these 3 ordered pairs, we are anticipating a horizontal line. Let's look at it and see. So for -3, -1, we're going to be here. And do we allow that to be a closed circle or an open circle? Well, the rule states that x is not equal to -3. So we're going to leave that circle open. And then we'll go to 0, -1, and 4, -1. Now, the 4 to -1 is our end point. So you have to ask, when I end this piece of the function, is this open or closed? Look at your rule. It states that we will include that point, so we will close this circle. And then lastly, we're going to graph the green piece. We have 4, 2, 6, 3, and 8, 4. And again, when we go to graph this piece, you have to ask yourself, is this starting point for this next piece, is it open or closed? Look at your constraint. It says x has to be greater than 4, strictly greater than 4. It does not say or equal to. So we will leave that circle open. Take a moment to pause this video and use this as an opportunity to find your domain and your range. Recall that when you find the domain, you're looking from left to right, and you're simply just writing down the interval on the x-axis from which your graph travels from left to right. And then your range, you're looking from the bottom of your graph to the top. What is your lowest point and how far does it go up? Are there any holes? Pause the video and do this. When you come back, you should see that from left to right, the graph started with negative infinity. And although there's a hole here, it picks up here. So this point is included. So there's no hole to account for there. So we have negative infinity to, and again, you see a hole, but it is accounted for in this graph. So there's no hole there. So really it's just negative infinity to positive infinity. So your domain is negative infinity to positive infinity. Now let's look at the range. The range goes from bottom to top. It starts with negative infinity and it goes up to here. And do you see there's a gap? Look at this gap here. So we cannot include those points. So our range stops here. So our range is from negative infinity to, what is this? Is to negative 3. So we've got negative infinity, negative 4 to negative 4. And that point is included. So we do have other areas in our graph though. So let's account for those. Here's a range at negative 1. So we do have a graph at negative 1. And then we have here, we're starting here again. Look, what is this y coordinate? That's positive 2, but that's an open circle, so we can't include it. We're going to have to use a parenthesis. And the graph increases into infinity. So we have 3 different pieces for our range, and we will marry all of these together with the U for union. So negative infinity to negative 4 with a bracket because see it's included here. Negative 1 is included because see we do have a point here at negative 1. And then positive 2 with an open circle to infinity. Email me if you have any questions.